Hello and welcome to this quick tech video on debugging a heterogeneous multi-core system using Xilinx SDK. In this video, we'll create a heterogeneous multi-core system consisting of the Cortex A9 processor on the processing system and a microblaze processor on the programmable logic using Vivado. We will then export this hardware to the software development kit, and then we will take you through step-by-step process on how to use this system debugger to debug these two cores. Let's open Vivado to create the hardware system. We will run a tickle file to auto-generate the hardware system. Now let's open the block design to see what's in the hardware. In this hardware design, we have a microblaze and zinc processor, both accessing the DPRAM through the AXE interconnect. Let's export this hardware to SDK. Select Launch SDK, click OK. After you have exported the hardware design to SDK, you can create an application project, one for the ARM core and another for the microblaze core. Let's create an application project for microblaze core as well. After you have imported the files for ARM core and microblaze and have built the project, you can debug the project. Click the debug configuration and select the system debugger. In this window, you will see a lot of configuration options. One of them is to configure the target and another to attach to a running target. If you click attach to running target, you can attach to a target which is already running. That's most helpful when you're trying to debug Linux kernel or stuff like that. If you click configure target, you'll see the bitstream that will be downloaded during initialization, as well as you can also see the ps7_init.tickle file which will be used to initialize the processing system. You can as well reset the entire system and program the FPGA. The steps that will be done before connecting to the target will be displayed in the summary window. Click on the application tab and you will notice the 3 cores that are detected from the hardware design. You can click on the download application for the microblaze core and you will notice the mb_app.elf is auto selected. You can click on the PS7 Cortex A9 and you will see the ARM application auto selected. If you click on the third core, you will notice that there is no application for this particular core. Click debug. The tool automatically programs the bitstream, initializes the processing system, and downloads the executable for both the ARM and microblaze targets. The microblaze and ARM cores will be suspended at their main functions. And when you click on microblaze target, the microblaze_application.c file will be highlighted. And when you click the ARM target, ARM_app.c file will be automatically opened. Simply relaunch the application and the tool automatically initializes the target and starts all over again. The debug configuration is just a one-time process. The tool highlights the memory locations that are recently written by the processes. You will also see a list of stack frames when you select a particular core. On clicking a breakpoint, you can select the breakpoint properties. You can choose to have a hardware breakpoint or a software breakpoint. You can also scope a breakpoint to a particular core. Also, you can select the actions that the debugger needs to take on the occurrence of that particular breakpoint. There are 4 different actions. If you click on APU target, you will see the list of registers that are on zinc peripheral. These registers are common to both the ARM cores. If you click on one of these cores, you will see the registers that are specific to that particular core. Similarly, you can view the registers for the microblaze cores as well. If you click on the microblaze application.c file, you will see the list of variables that are there in that particular executable. Similarly, if you click on the arm_application.c file, you will see the variables that are there for the ARM executable. You can also use this system debugger to debug Linux kernel. As a next step, talk to your local sales team for a detailed SDK product presentation. Refer the user guide 940 to know about co-debug and cross-triggering. Also try out the system debugger using the steps provided in the Zinc Concept Tools and Techniques guide. On behalf of Xilinx, thanks for watching this video.